Episode 6. Nothing new under the rain. Cities that learn to slow water down. Whenever a simple solution is proposed, skepticism follows. It sounds reasonable. It sounds logical. And then comes the doubt. If this really worked, wouldn't others have done it already? The answer is yes, they have. Capturing rain where it falls is not a new idea. It is not experimental. It is not a shortcut born of desperation. It is a lesson many cities learned only after expensive mistakes. In highly urbanized places, engineers eventually reached the same realization. You cannot drain your way out of flooding forever. When surfaces are sealed and rainfall intensifies, speed becomes the enemy. The only sustainable response is to slow water down before it overwhelms the system. That is why many modern cities quietly shifted strategy. They still build drains, they still use pumps, but they added a missing layer: local storage and delayed release. Roofs were turned into collectors. Buildings were required to store part of their runoff. Neighborhoods were designed to hold water temporarily instead of rushing it away. The goal was not to stop rain, but to desynchronize it, to prevent thousands of small flows from arriving at the same time. The result was not dramatic headlines. It was something better: fewer flooded streets, shorter flood durations, and more reliable water supply. What these cities discovered is deeply relevant to places like Metro Manila. Flooding and water shortage are not opposing problems. They are symptoms of the same imbalance. When rain is expelled too quickly, streets flood briefly, but aquifers remain empty. When aquifers are empty, water shortages appear. Cities are left dealing with both extremes, sometimes in the same year. The Philippines, despite its abundant rainfall, experiences this contradiction constantly. We are flooded during storms and short of water during dry months. Not because nature is unfair, but because our systems treat rain only as waste. What other cities learned, and what we are now rediscovering, is that rain must be received before it can be managed. Distributed rainwater capture works not because it is clever, but because it aligns with how water behaves naturally. It restores a pause that cities removed. It gives systems time to cope. Most importantly, these cities did not begin with massive rollouts. They began with pilots, small districts, selected buildings, measured results, adjustments, scaling only after evidence. This is why the idea matters here. Nothing being discussed is radical. The technology is simple. The logic is well understood. The risk is low. What is missing is not proof, it is application. The question facing communities like BF Homes is not whether this idea is new enough. It is whether we are willing to learn from places that already paid the price of ignoring it. In the next episode, we return home and face the most difficult question of all. Will this actually make a difference in BF Homes? Or is it just another good idea that sounds right but changes nothing? Episode 7. A combined low-cost approach: detention chambers and proportional water storage. Flooding and water shortage are often treated as separate problems, addressed by separate solutions. This chapter proposes a combined approach that recognizes them as two sides of the same issue: water arriving too quickly during the wet season and leaving too quickly afterward. Minimal intervention. Along existing creeks, the first component introduces detention chambers along selected sections of existing creeks. Importantly, the entire creek is not excavated or rebuilt. Most of the canal remains exactly as it is. Only short, strategic segments are refined to act as temporary storage during heavy rainfall. These detention chambers remain inactive during normal conditions and function only when excess water needs a place to wait. This targeted approach keeps costs low, minimizes disruption, and avoids the social and legal challenges associated with large-scale canal reconstruction. The emphasis is simple, ain't it? Do not dig everything. Dig only where it matters. Proportional responsibility. Through roof-based water storage. The second component introduces mandated household water storage applied only to buildings with larger roof areas. The principle is straightforward. Larger roofs generate more runoff and therefore carry greater responsibility. Smaller homes are not burdened, while larger residential and institutional structures are required to provide modest on-site storage. This storage captures roof runoff before it enters the drainage system and encourages basic water conservation without imposing uniform requirements on all households. Why the two concepts work best together. Detention chambers and roof-based storage serve different but complementary roles. Detention chambers manage large volumes of floodwater at the system level, reducing peak flows and protecting communities. Roof-based storage reduces immediate runoff and promotes responsible water use at the household level. Neither solution attempts to replace the other. Instead, they work in parallel, one structural and automatic, the other distributive and proportional. A concept worth deeper study. This combined approach is intentionally modest in intervention and balanced in responsibility. It avoids over-engineering, spreads costs fairly, and allows phased implementation. For these reasons, it represents a practical and defensible concept worthy of deeper technical, economic, and policy study. Episode 8. Will it really work here? What this can and cannot solve in BF homes. At this point in the discussion, the most reasonable question emerges. Will this actually work in BF homes, or is it just another idea that sounds good on paper? The honest answer is this. It will not eliminate flooding entirely, and it was never meant to. Flooding in BF homes has multiple causes: intense rainfall, flat terrain, aging drainage, high tides, and downstream congestion. No single intervention can solve all of these at once. Expecting a small tank to do what mega projects promise is unrealistic. But dismissing the idea because it does not solve everything is a mistake. The right question is not whether rainwater capture is a complete solution. The right question is whether it meaningfully reduces the problem. And here the answer is yes. By capturing rain at the roof level, the system directly addresses peak runoff, which is the primary trigger of street flooding. When thousands of roofs delay even a portion of rainfall, the combined effect reduces the sudden surge that overwhelms drains. Water levels rise less. Flooding starts later. In many cases, streets that would have flooded may no longer do so. Even where flooding still occurs, it becomes shallower and shorter. That difference matters. It protects vehicles. It reduces damage to homes. It allows pumps and drains to operate within their limits instead of failing under stress. Equally important is what happens when it is not raining. Stored rainwater used for flushing, cleaning, and gardening reduces demand on the main water supply. During dry months, this eases pressure on distribution systems and reduces reliance on groundwater extraction. Over time, this helps slow land subsidence, one of the hidden contributors to worsening floods. So the benefit is twofold. Less water during storms, less demand during droughts. What this approach cannot do is replace all other flood control measures. Drains still matter. Pumps are still needed. Rivers and outfalls must still be maintained. But these systems work best when they are not asked to handle everything at once. Think of rainwater capture as load reduction, not replacement. This is why BF Homes is an ideal place to test the idea. The area is large enough to produce measurable impact, organized enough to implement standards, and visible enough for results to be studied honestly. A pilot project would not require belief. It would require measurement. Did flood depth decrease? Did flood duration shorten? Did water demand drop? Did pump usage change? If results are modest, the program can be adjusted. If results are strong, scaling becomes justified. This is how good engineering decisions are made, not by promises, but by evidence. The real risk is not trying something simple and measured. The real risk is continuing to spend large sums chasing water downstream, while ignoring thousands of small opportunities upstream. In the final episode, we bring everything together. Why starting small, testing locally, and scaling carefully may be the smartest flood control decision we can make.